How do we organize data in IoT systems? So there are lots of ways to organize data, lots of different database technologies. So I'm just going to discuss a few different ideas we've been thinking about lately. So anytime you have a set of data, there's multiple perspectives, or things we're keeping, perspectives on things we're keeping track of, or data we've collected. With IoT systems, we might have the location of devices that we're interested in. We also may have different perspectives such as organizational structure, different roles, and there might be functional groups that cut across physical locations such as maintenance groups, management, people who are interested in energy usage, and there's just a lot of different perspectives that we can look at data. And as we consider our data, there are several operations we might want to do. We might want to find a device by location. We might find a location of a device. We might move devices around to new locations. We want to get the current state of a location, so that would collect all the information for all the devices at that location. And perhaps the most important thing with IoT systems is, since they're distributed, we need to sync subsets of data from each device, typically upstream to a cloud system where we aggregate all the information from all the devices. So we need to sync a subset of the upstream data with each downstream device. And lastly, we want to get historical data, and we often want to filter by location, the type of device, a value range, and a duration that the value needs to be valid for. So in manufacturing, people think about location a lot, and they're trying to manage manufacturing assets or materials. So there's this ISA 95 standard, and it suggests you use the following attributes for location: enterprise, site, area, line, cell. So I'm just going to use this as an example. Lots of other applications may use different ways to track location, but this is just one example. So an SQL approach is we're very familiar with SQL databases. They're very common, very good. And in that approach, we'd have a separate table for each type of device data. So we might have a users table, a device table, and then maybe a group table that would be used to link users and devices. So a group would contain a set of users and a set of devices, and then those users would have access to those devices. Location information might be in yet another table, or it could be stored with each device with each entity as a key value pair. So another approach is the graph approach, and in this case we have a hierarchical graph, and this graph is used to establish relationships between the entities in the graph. So let's just switch to a Simple IoT example. In this case, we're going to have a site, so we're just roughly following the ISA 95 with simplifying a little bit. So I have a site, we'll have two lines, and each line will have a number of cells. And let's zoom out a little bit so we can see more. And then additionally, we can add users or rules at any level in this graph. So in this case, line 1, the user 1 would have access to all the line 1 stuff. Also have access to all the line 2 stuff. user 2, in this case, would only have access to the cell 1 stuff. So this is a way a graph might be used to establish relationships between users and entities and different things. So to illustrate this, I'm going to open up a separate window and we'll log in as user 1, and you'll notice all that they see is their line stuff. So let's log in as user 2, and user 2 is in the cell 1 group, but he's also in a maintenance group. And then if we log in as user 3, we can see user 3 only belongs to the maintenance group. So what we're doing is we're using a tree, and how this works is entities in the tree can exist in multiple places. So if we look at the maintenance group, we'll see that machine 1 and 2, which are from lines 1 and 2, also exist in the maintenance group. And to show these are the same entities, let's say the maintenance, a person in the maintenance, a maintenance person is going to shut machine 1 off. And then we'll see that in the perspective of the site group, the machine went off. So this shows that these nodes are connected. They're the same node, they just are mirrored in multiple places in the tree. So the way this works is this maintenance, all these attributes here, these are just groups. They're the same type of node, same type of entity. So there's nothing special about these groups. They're just simply ways to collect other nodes underneath of them. So using this, you can have as many different perspectives and ways of looking into this as you want. So we need the ability to query history, and let's go back over to the browser. So let's say that machine, the temperature sensor, we had it on line 2, cell 2 for a while, but we wanted to move it over to cell 1 on line 1. So we can move that. So I'm going to say move here. So now the temperature sensor is over on line 1. But yesterday and last week it was on line 2, so that data existed on line 2. So we have to be able to know what devices existed where throughout history. So with the SQL tagging approach, where we tag every piece of data we put in our historian, this is pretty simple. The tags are there and they don't change, so we can just query it. With the graph approach, it's a little more complex because we're not storing all the tags and all the tree history with every node. But what we are storing in our historian is the history of these relationships. So in the historian we have records that temp1 used to be part of cell 2, and we can look back through a history, and what we do is we have what we call edge points, and these edge points describe relationships between nodes. And any time one of those edge points, if we delete a node, we set a tombstone flag, tombstone point in that collection of edge points, and that's all stored, so we can query that. Additionally, we can, now that temp1 is part of cell 1, we can occasionally write maybe a tombstone point, maybe every hour or every whatever interval you want, into the historian, so that we can easily query over some minimum time span, and we can see if that point existed in history, and then we know that that device was available during that time. So it's a little complex, but it's still very possible. And the advantage is when we write the temp1 data, all we need to store in the database is a UUID for that temperature sensor. All the other metadata is stored elsewhere, and it's not repeated for every data sample. The other big advantage this gives you is one thing people always end up wanting in IoT systems is they want to know who changed what when. So we get into these cases where something changed in the system and nobody knows why, nobody knows who did it, nobody knows when it was done. And if we store metadata as auxiliary data, like as key value pairs, we don't, unless we design another mechanism on top of this, we don't have a way to know when things changed. But if we store this information as points in nodes, and everything's a point in a node, and everything gets written to the historian, then anything we do is recorded. So we can easily audit the system, and additionally, when we change a point, we also record who did that, the node ID of who did that, if it wasn't the node that owned the point. So I guess in summary, the SQL method is widely used and it's flexible, but it seems to be optimized for large, complex, interrelated data sets. This might be like a warehouse system, order entry system, accounting, things where you have thousands and thousands of, or even millions of rows of data, and lots of different types of data that are described in complex, interrelated ways. So I feel that IoT systems are a little bit different. You have a much smaller set of entities you're working with because the number of physical devices you can deploy, at least complex devices like the ones we're talking about, are numbered in the thousands and maybe 10,000s if you're lucky. But it's not a huge data set. Likewise, the number of users. This isn't a social media site where demand will shoot through the roof one day and then be back down. It's a pretty constant set of users that's fairly small, and it will be growing slowly. But in an IoT system, the structure is the relationships between the entities are very important, and if we can easily manage those relationships, then we can quickly make changes. We can move a whole set of data from one place to another. And I'll just show you one other example. So in this case, we have several rules. So this site 1 rule is located at the site level, so it would apply to any data that flows up from any of these lines. Inside line 1, we have a line 1 rule that would only apply to devices in line 1. So in this way, we can scope things very easily. Instead of writing a rule for every one of the devices in line 1, which there may be hundreds of them or more, we can write a single rule, and then we can put that at any level, and then we can scope that to whatever we want. So anyway, just some brainstorming, some ideas. Thanks.